Hello everyone! My name is Denise Maldonado. And welcome to the geometry of a bicycle. From cameras to playgrounds to even bicycles. Math isn't everything. There are bikes everywhere, all over Chicago. Even on your chemistry field trip. Like you and me, bicycles come in all shapes and sizes. First, let's go back in time. The first bike in history was made in 1418 by Giovanni della Fontana. It was actually a human-powered device made of 4 wheels and a loop of rope connected by gears. Moving forward onto the most popular forms of the bicycle, the penny farthing was created in 1871 with its large front wheel and much smaller rear wheel. Nowadays, the bicycle comes in different forms such as BMX bikes, road bikes, mountain bikes, cruisers, and cyclocross bicycles. The difference between each lies within their purposes, which can be attributed to triangle inequalities and differing measurements of specific parts. This is where geometry is essential to understanding bicycles. It's important to know a bike's geometry so that the rider will understand how it will handle, feel like, and compare to other bicycles. Each bike serves a different purpose, and each part of that bike is modified to serve that purpose. The modern and most commonly used frame, the diamond frame, consists of the main triangle and paired rear triangle frame. The main triangle consists of the head tube, top tube, down tube, and seat tube. The rear triangle consists of the seat tube, paired chain stays, and seat stays. The two most fundamental elements of bicycle geometry are stack and reach.
What is stack?
It is the vertical measurement from the bottom bracket to the top of the head tube. What this indicates is the height of the bicycle frame. Reach is the horizontal measurement of the bottom bracket to the top center area of the head tube. This measurement is especially important because it may improve the aerodynamics depending on the body type someone may have. Now that we've established the two most important details in the geometry of a bicycle, let's dive right into the details. The head tube of a bicycle will affect the handling depending on its angle and length. A slack or steep angle will determine how much effort is needed to properly handle the bicycle, while the length will affect the frontal profile of the rider, meaning an upright position or a position more suitable for racing. The responsiveness of a bicycle is determined by the fork rig. By increasing the angle, it will make steering the bicycle faster, as well as increasing the wheelbase and creating stability in the bike. The wheelbase is the distance between the front and rear dropouts. The length of the wheelbase is determined by the head tube angle, the fork rake, and the chainstay length. This is especially important when it comes to the rider. If one wants stability, comfort, and a natural compliance, a longer wheelbase is important. Better handling, more responsiveness, and a performance-oriented model, a shorter wheelbase is more likely.
So what's the point?
The rider and the bicycle form 3 triangles. But in order for the bicycle to correctly function, it must maintain the triangle inequality theorem. The theorem states that the sum of any 2 sides of a triangle must be greater than the measure of the third side. And with these understood triangles, the bicycle is then responsive to the environment, has traction, the ability to handle, and riding position. So, why triangles? Well, the triangle is the most rigid and strongest shape of all. Triangles have the ability to spread the weight and are thus able to hold more weight compared to a square. When it is subjected to force, it maintains its shape. It forms the simplest rigid structure and cannot be distorted to make another shape. Therefore, it is the most favorable shape to use in the design of a bicycle. Hence, why it was important for us to use triangles in our bridges. With the parts of the bicycle varying in measurement, the bike will differ from person to person and bike to bike. Always remember to choose a bike that is suited to your needs and keep cautious. Remember to wear a helmet, watch out for other moving vehicles, and adhere to the rules of the road. Thanks for watching!
Hi, I'm
Megan, and I'm a mechanical engineer.
Hi, I'm Patty. I do the same.
And we endorse this message.